Hello everyone, welcome to my YouTube channel Learn GCP with Mahesh. So in our today's video in Think and Design in GCP video series, the question is something like this. By default, every project will have 5 VPCs. That is the default quota. You can increase that by raising a request, but the default is 5 VPC. That is a thing which everybody should be aware of. So this customer also has the same quota limit, but the customer has a special request or a special requirement. The requirement is each VPC should not be able to accommodate more than 4 virtual machines or one Kubernetes cluster which is of more than 4 node cluster. It should not be a more than 4 node cluster. So that is their requirement. They want to put this restriction. So how do we achieve this? So if you want to think about the solution, pause the video and think about it, and let me know your thoughts and comments in the comment section. Now, what I will do is I'll jump into the solution. As usual mentioned, the solution which I'm trying to propose is not the best solution. It is one of the possible solutions which I have thought. So if you have some better solutions, please put it in the comment section. Now, before we get into the actual implementation of that requirement, we need to understand some basics before we proceed further, because the number is very important. They mentioned they want only 4 virtual machines or a 4 node Kubernetes cluster to be provisioned. You cannot provision a 5 node Kubernetes cluster or anything above 4 node. You cannot provision it, or you cannot create 5 virtual machines together. So that is the requirement. You should be 4. That is the thing. To understand that, so if you just come to this page, there is something special about this page where they detail about what needs to be created when you create a CIDR range. When you create a VPC, you will create a subnet, and for that subnet you will give a CIDR range, right? And in that, not every IP will be accessible to you. There is some reserved set of IP address. For example, if you click on this reserved IPs, they mention you this. If you give a CIDR range, out of those CIDR range, whatever the number of IPs it can accommodate, out of those, 4 are reserved by Google. The first one is for your primary address range. So it is something like 10.1.2.0. So that is reserved. Then the default internet gateway. This is for you to connect to the internet. So this is getting reserved. And from the last but two, this is used for potentially for a future purpose. So for futuristic purpose, they are reserving it. And the last one is your broadcast IP. So 4 are reserved, meaning whatever you do, the CIDR range, it should be in such a way that it should be always plus 4. So since the customer has mentioned they want only 4 machines to be reserved or created in one VPC with this 4 reserved. So what you should do is the CIDR range should be in such a way that minimum you should be able to allocate 8 IP address. So that is the most important thing. So usually for the people who are beginners in the networking concept, creating a CIDR range with only 8 IP address could be slightly difficult. So I thought let me take a use of this website, mxtoolbox.com, where they give you a calculator. So very nice calculator. So if this is my CIDR range, and say for example, if I choose my subnet mask, or the network mask to be very specific, 24 bits would be reserved by the network itself, meaning the first 24 bits would be reserved, only the last 8 bit would be available for your VMs. So with /24 you can address almost up to 256 IP address minus 4, because those are reserved. So if you have the /24, you'll be able to accommodate 252 IP address. Now the requirement is only 4 VMs or 4 IP addresses should be allocated. For that, what you can do is you can use this /29. So if you use this, the maximum IP address which you can allocate is 8. That's it. Minus 4, you will get back your 4 thing. So the requirement which the customer has mentioned, we'll be able to fulfill if you use /29. So with this background, let's go and create our magic VPC. The reason why I named it as magic is this is a weird VPC which has only 4 VMs which it can accommodate. So that was the reason. And let's create the subnet in Mumbai this time. And let's copy this the CIDR range, and paste it here. If I mention it as 24, I'll be able to accommodate 252. That is not I want. So if I make it 29, I will get it. And Google has put a restriction on this. It's very smart, I would say. If you try to do 30, for example, if you just come here /30, what you get is only 4. If you put /30, because we know 4 is already reserved, if you have a /30 mask, what happens is you will not be able to create any virtual machines. So that sub network is of no use. So that is the reason why they have mentioned the range mask cannot be greater than 29. So hope you understand why this message comes now. So because of that reserved IP address. So let's go back to 29. That should be all good. Click on done and click create. All right, the VPC and the subnet has been created successfully. What we'll do is we can test it whether this is really allocating only 4 IP address or not in two different ways. One, create individually 4 times a virtual 4 instances. The fifth compute engine, when you create, it will show the IP address is exhausted. So that is one way. So I'm being a lazy person. What I would try to do is I'll try to create a Kubernetes cluster. It is easy. I'll create a Kubernetes cluster which is like a 5-node Kubernetes cluster. So it will definitely throw me the error after the 4th node is provisioned. So that is what we are going to do. So this is our magic Kubernetes cluster. We are going to provision it in Mumbai because that's where our subnet is there. And the most important thing is mention the number of nodes as more than 4 so that we will see whether this is going to work or not. So I have made it as 5 and make sure the network is magic VPC. That is the stuff. Let me click create. So let's wait for the cluster to create and what is the error it shows. So by the time this creates, what you can also do is you can also click on the hamburger menu, go to your compute engine screen, and you should see the cluster. Because behind the scene it is nothing but a managed instance group, Kubernetes cluster, the nodes. You should see 5 virtual machines. 4 would be definitely able to get an IP address. The 5th virtual machine will not get the IP address. Still nothing has been provisioned, so still it is going on. So let's hold on here. So if I just refresh it and try to refresh the screen, I should see something. If I don't see it, we need to wait for that. So it's just in process. Nothing has popped up yet, so let's wait for it. All right, you see 5 virtual machines have been provisioned already, and the first 4 have already got their IP address range. This is the unfortunate compute engine which will not be able to get its IP address, because of which you will get this error. You already got this error here. Let's see this message, or maybe you can just click on this message to see. You see this? Not all instances are running in IMG after this. So the reason is exhausted. The IP space is the IP space is exhausted. That is what it indicates, and that is something which you will also see here. You see the fifth virtual machine was removed automatically, and since this cluster is not completely created, you will not be able to use it fully. So the only option is you need to delete it. The moment you delete it, the 4 compute node will be removed automatically. So this is one way of testing whether you have your cluster, the requirement of the VPC should have only 4 virtual machines, or a Kubernetes cluster of 4 node or not. So what we will do is we'll quickly try to create a Kubernetes cluster which is only 4 node, so that we can verify that this requirement is fully done. So I did one with 5 nodes just to show you that what happens if you exceed more than 4 nodes, what is the error you get. So you get that exhausted stuff. So if you just click on this, you should see that message, IP address is exhausted. So that's what it indicates. So let's create a new Kubernetes cluster. So all right, I have deleted that cluster which was a 5-node Kubernetes cluster, and I have tried to create a new cluster with the same name, but the only change which I have done is the number of nodes are exactly 4. So if we do this, definitely it should work. That's our understanding, and please make sure it is using the magic VPC. So if you see, it should be your magic VPC. That is a step. Let's click on create and wait for a couple of minutes. that should show a fully functional 4-node Kubernetes cluster. Let's wait for that. So all right, our 4-node Kubernetes cluster has been successfully provisioned. You see a green tick and you show that size. And if you want to verify the number of virtual machines created, just go to your screen, Compute Engine screen. You should be able to see it. And it should also show this message, the Kubernetes cluster is provisioned. Looks good. Now one last try to just check whether for the compute engine also whether this is working fully or not. What I would do is, now the life becomes very simple. You already have 4 virtual machines. If you try to create the 5th one, they should also give you an error. So this is another way of testing it. So let's try this one last thing and see whether it gives an error or not. So let's make it anyway, whatever the range, whatever the machine type you give, anyway it's not going to get provisioned. Make sure you click on the networking and select the right VPC. It has to be our magic VPC. Select it, click done and click create, and you should definitely expect a error message saying that the IP address are exhausted. So no more IP address available. That is what you should see. Let's wait for that to pop up, and that should conclude that we are able to fully achieve the requirement the customer has mentioned. So let's just wait for a minute here. So the cluster, sorry, the virtual machine is trying to get provision, but it will not be able to provision it. So if I just refresh it, okay, you see this, the internal IP address, it's not able to still get allocated. Still not. You should see the error message soon. That's it. You see that message? Exhausted. The IP space is exhausted in this VPC. That is the message. So nothing can be done. That's the restriction which we have put. So simply dismiss it so that it vanishes away. So the crux here is to fulfill it. The entire thing here, the most important stuff I would say is in this design is /29. That is the most important thing by which you were able to achieve this. So if I just open it, this was, so that is for the Kubernetes cluster which you have done. So this is your IP address range. So the /29 was something which will made you to achieve the requirement which was mentioned here, like only one VPC should be able to accommodate only 4 VMs. So by doing this, we understood what is reserved IP address and how you can restrict the IPs, number of IPs generated from a VPC. Hope the video is helpful. Thank you for watching.